So we look at question 14. They said determine our cotangent square 2 theta sine cube 2 theta. So we can see our cotangent and sine cube here. So actually, how we going to simplify? How we going to find this integration? We can do our simplify first because we can see cotangent. We can simplify it, and they're having the same data. They're having the same angle, which is 2 theta. So means we can simplify our trigo. So for cotangent, we're going to express cotangent is cos over sine. So when we have square means cos square 2 theta over sine square 2 theta. And then time with, here is sine cube 2 theta. So of course, when we're using the unknown data, they were respecting to data. So that's why here is d theta. Okay, so from this question, after we look at our cotangent square, we simplify into the form of cos over sine. We can simplify our questions. So actually, this question is not so hard. You can see sine square, we can simplify become sine 2 theta. So our questions here just cos square 2 theta time. So I will put bracket time sine 2 theta. Okay, so this is our simplified form. So after we see sine and cos, so sine and cos, they are friends. They are differentiation friends, right? So differentiate cos, we get sine. Differentiate sine, we get cos. Just positive, negative in answer only. And then we can try to use our formula. So here we come. We can find this formula. You can see giant function. No, although it's just power of 2, but it is fulfill the characteristic when we have function and differentiate function at the side here. They are multiplied together. We can use the giant function. The whole function power plus 1 over power. Okay, so from here, we can see our fx. So we can let our function as cos 2 theta. We try to differentiate. So we try to differentiate. When we differentiate cos, we get negative sine. And then when we differentiate its angle, we get 2. Okay, when we differentiate cos, we get negative sine. This is our last sem syllabus. Differentiate cos, we get negative sine. And then differentiate angle, we get 2. So we can see here, is it this question fulfill our pattern where this is fx? Okay, so its f prime x should be. So our f prime x here should be negative 2 sine 2 theta. But what we have here is just sine 2 theta. Okay, the function is there. You can see function is there, but the coefficient is different. The coefficient here is 1. Here is negative 2. When the coefficient is different, we can multiply in our new coefficient. So what can we do for this question is, we're going to multiply in negative 1 over 2. So for these questions, cos square 2 theta, I'm going to multiply in our negative 2. But when we multiply in our negative 2 means we are changing the question. So in order to maintain back our question, we will divide back. So this is how we multiply and divide back. So our question still same, but we meet the pattern that we want. So we multiply negative 1 over 2, so we will divide back negative 1 over 2. So in terms of questions, the level of question, they are same. But the pattern we have is we managed to find our f prime x. So this is our fx, this is our f prime x. So when we get that pattern, when we get that characteristic, means we can use our formula, which is our function. So when we see fx and f prime x, our function will be power plus 1 over new power. So our function here is cos. So our cos power plus 1 become 3 over new power. Then plus c. So finally, we simplify the numbers here. So it will become negative cos 2 theta over 6 plus C. Okay, so therefore we look at our marks here. So when we want to express our formula, so that is very important. You indicate which is your function, which is your differential function. So this is our function, this is our differential function. So our concept is set here to alter our coefficient so that we can use the formula of giant function to get to the answer. Okay, so that is how we get these 5 marks.